So you talked earlier about the core technology that you built to enable this, the radiator thing with the cooling. Yeah,
Yeah.
can you maybe explain how that works?
Yes. So just to illustrate the point, when you are, yeah, the one of the biggest power usages of a terrestrial data center, maybe 20% of the power in an efficient data center goes into cooling. And usually the heat sink of that cooling is a cooling tower, which is essentially boiling fresh water. So we don't have that in space because we don't have large amounts of fresh water to boil and we don't have an atmosphere. So we need to find a new way of dissipating that heat. And the way you do that is by what's called black body radiation, which is essentially where you just have a large black panel or surface, and that will emit infrared if you keep it at a certain temperature. So if you keep it, we're planning to keep our radiators around 50 or 60 degrees, and that will on the cold side even, and that will emit around, I think it's 800 watts per square meter, and the solar panels generate around 200 watts per square meter. So we need about a quarter the size of the radiator. So a quarter the size of the solar panel needs to go into a radiator. Um, Now, if you have a kilometer by a kilometer solar panel, that means you would need to have 500 by 500 meter radiator, and that obviously means pumping enormous amounts of fluid. Dissipating heat through that distance is actually extremely challenging, and so that's essentially where all of our efforts going. The biggest radiators right now are on the International Space Station. As I understand, they're dissipating around 70 or 80 kilowatts. We're Our radiators potentially, when we're up to a megawatt, it's like 10 times that size. Um, so yeah, it is possible. It's just expensive right now. So we know it's possible because it's done on the ISS. Our challenge is, can we do this cheaply and with low mass, and mass produce them?
Right.
And
And
I won't go into the exact secret sauce of how we're doing that because that is truly our secret sauce.
I see, I see. Okay, and so you launch it up with SpaceX, then you build a data center, you have the solar panels for the energy, and they run, and then you dissipate the heat, and then how do you transfer the data back? I guess that's the life cycle of the entire operation.
Yeah, I mean the data transfer back is pretty much solved now because of the mega constellations. So constellations like Starlink and Kuiper and Kepler. So we'll in the end state we'll be using optical. So we'll plug into one of these mega constellations. You have very high data rates using lasers. So I think it's public that Starlink lasers are a 400 gigabit a second data rate. You can have multiple, you can have 10 lasers coming off this thing. Can't point in the same direction because they interfere, but yeah, I think the physical limit is around a terawatt per laser, when you're using basically every frequency within the laser, or as many as you can. Um, so yeah, that's the way that we get the data back.
Okay. So which part of this is like the hardest? The launch, the energy, the maintenance, or the transfer of data?
The bit that is unsolved right now is the radiator, and that's the bit that we're
Right.
solving. Yeah,
Okay.
launch is solved, transferring data is solved. Um, Maintenance also needs to be solved, but I think we're moving in the right direction. But what we're working on is the radiator.